This conference will now be recorded.
In the last class, we started with collections. The main use of going with collections is to collect the elements of variable size. And we have seen the collection hierarchy. So the topmost two interfaces are collection and map. Collection is used only to collect elements. Map is used to collect elements in the form of key value pairs. Then, under collection, again we are having two sub interfaces like list and set. List is ordered, set is unordered. List does not allow duplicate elements, whereas list allow duplicate elements, set does not allow duplicate elements. Then under list, we are having two subclasses like array list and linked list. When you go with array list, the elements are stored in continuous memory location. Linked list, non-continuous memory locations. So when you go with array list, the cost of insert and delete operations are more, whereas it is less in linked list. Then under set, we are having subclasses like asset. Asset is unordered, no duplicates. Linked asset is ordered, no duplicates. Tree set is sorted and no duplicates. Similarly, under map, hash map is unordered based on keys. Linked hash map is ordered based on keys, and tree map is sorted based on keys. In map also, no duplicates. Now, let us go with the coding part. Before that, let us see the methods of list entities. Some of the methods it has taken from collection interface. So the methods are like boolean add, which takes argument object. So why object here? Because in collections we can add only reference type, and what is the topmost reference type? Object. So the argument here is of type object. Any type of object we can add. What is the use of this method? Adds an element at last. The return type of this method is boolean, meaning if the element is added, it is going to return true. Unable to add, returns false. Then we're having one more, add int comma object. The use of this method is adds an element at the given index. So whatever the index we provide, this element will get added. Void set int comma object. Set is for update or modify the element at given index. So whatever the index we provide, at that index the element will get updated. Boolean remove object. This is for delete the given element. Delete the given element. What the element we pass, that element will get deleted, and it's going to return true if it is delete. If it is deleted, it's going to return false if it is unable to delete. Why it is unable to delete? If the element is not present in your list, it's unable to delete. Object remove with index based. So this is going to delete the element at given index. It's going to delete the element at given index. Then, and what is the element it deletes? It is going to return that element. Object get method with index based returns the element at given index. Size method returns the number of elements. Now let us understand all these methods using the code. Let us understand these methods using array list class. Let's go with the program. Array list. Open Eclipse. To store collection related programs, let us create a new package, collections. In this, let us create a new class, array list. with main method inside. Now, so all these collection classes and interfaces are present in java.util package import. So import java.util package. Now, whichever the collection class we want to use, just we have to create the object of that class. In our example, it is array list. Array list al equal to new array list. Then add the elements. How to add is simple. Al dot add, pass the element which you want to add here. Al dot add 20, al dot add ppp, al dot add qqq, like this. Now if you print the object al, see the result how we are going to get. It's going to show the elements separated by comma enclosed in square brackets. And the way we add it, the way we are getting. That's the meaning of ordered here. That's meaning of ordered. So here we get 10, 20, ppp and qpp. Now, if you add one more element, al dot add 10. See, when you run this code, see even the 10 is getting inserted. So it is a duplicate element. 10 is already added. Again, we are trying to add the same element. So duplicates are allowed here. So even we can able to add duplicates. Clear up here the meaning of ordered and allowing duplicates. Any questions? No. Let us see the remaining methods. When you are saying al dot add 2 comma 2 comma xxx. Now if you print the object al, now the result will be 10, 20. xxx will get inserted. So this ppp and qqq will be moved to the next location. So this will get moved to the next location. So in second index 0, 1, 2. In second index, this ppp will get inserted. And here we'll be having ppp, qqq, and the elements will be shifted to the next location until you get space where you want to insert. In the case of array list. Now, if you are writing al dot set 2 comma y. So second index element will be replaced with what now? Y. 10, 20. Second index will be replaced with y. Then ppp, qqq, and 10. Now if you are writing al dot remove y. So this y will get deleted. Now if you print the object al, now the list will be 10, 20, ppp, qqq, and 10. Now if you are writing al dot remove of 2. So what is the element at second index? 0, 1, 2. This is second index. So ppp will be removed. If you print the object al, now the list will be 10, 20, qqq, and 10. Now if you are writing string s equal to al dot get of 2. See what is the element at second index? 0, 1, 2. This is second index. So qqq will be returned. Now if you print the value of s here, the result will be qqq. But observe, under get method, we are getting error because the return type of get method is object. What is the return type of get method? Object. So we are having object in hand and you are assigning to which type? String type. You are assigning this object to what here? String here. So you are doing conversions. So if you remember typecasting, so we have seen typecasting for primitive type in basics. So when you go with typecasting for primitive, we see the sizes. We see the what sizes like 8 bytes, 4 bytes, long to integer, integer to long, like that. right? We see the sizes over there. But coming to reference type, here object and string are reference type. When you come to reference type, we have to see the hierarchy. So object is superclass of string, means object is higher and string is lower. So when you come to reference type, we have to see the hierarchies. So since object is superclass of string, object will become higher, string is lower. That's the reason we are getting error. We are trying to convert higher to lower. So here, since we are trying to convert higher to lower, we have to apply the typecasting. Just to keep mouse pointer on this error, and you can see the option C, add cast to string. If you click here, it's going to apply the typecasting. Clear this concept, all of you? Typecasting between reference types. Now, size equal to al dot size. How many elements are there finally in the list? 4 elements. So we are in total 4 elements in the list here. Now see, when we run, we get same output, somewhere error. So we missed out double quotes over here. Now see, when we run, so we are getting the same output what I have given in comments. Clear, all of you? Any questions? Now, if I replace this array list with linked list, if we replace array list with linked list, then it is same output, no change in the output. Then what is the difference? Performance. So performance wise, add method, remove method will work more faster in the case of linked list. Okay, so performance difference is there here. So when your application is having lot of insert and delete, make use of linked list class over array list. That part we should do. Now, in linked list also we can use all these methods. Other than this, in linked list it goes with some more additional methods. Additional methods in linked list. Self-explanatory, that is add first, add the element at first, add last, add the element at last, remove first, delete the first element, remove last. So these are some more additional methods we can use in linked list class other than these methods. Now, moving to the next one. See, here we are able to add 10 and 20. 10 and 20 are what? Primitive type, integer primitive type. But we are able to add. But at the beginning we discussed, in collections we can add only reference type. But how it is able to add this primitive type? Because of a feature, auto boxing. Because of what feature? Auto boxing added in Java 5 version. So what is this auto boxing is? Even though you pass primitive, it's going to convert into reference type. What is auto boxing? Converting respective primitive type into reference type or vice versa, means reference to primitive automatically. This feature is known as auto boxing. This feature is known as what here? Auto boxing. Right? Now, so prior to Java 5, we used to write the code like this: al.add new integer of 20. This is the way we used to write prior Java 5 version. So we used to convert into reference type and add it. But this is not required from Java 5 because of what feature? Auto boxing. When you run this code, it is showing the elements in square brackets separated by comma. Now the objective is we want to pull out one element and use it. What is our objective? We want to pull out one element and use it. That concept we call it as traversing. That concept we call it as what? Traversing or iterating. What is traversing? Accessing every element of a list or set. This concept we can even apply for set. Accessing every element of list or set is called as traversing. One more concept here. In this list, what type of elements we are adding? Different type. Now we want to ensure in our collection, we want to go with only similar type of elements. So when we want to ensure to add only similar type of elements in collection, we make use of a concept called as generics. Generics is very important but very simple. Generics in collections. Generics are added in Java 5 version. Generics are used to manage different data types. Generics are mainly to manage the different data types. And the advantage of generics is when generics are used in collections, we can ensure that only similar type of elements are present in collection. So when we use generics, we can ensure only similar type of elements are present in collection. And one more advantage is when generics are used in collections, we can traverse the elements of collection using enhanced for loop. Using what? Enhanced for loop. Now, let me elaborate this using a program. Generic collection.java. Right click on collections package and say new class generic collection with main method. Import util package. Now create object of a collection class. Let me go here with LinkedList. LL equal to new LinkedList. Now add elements. LL.add. LL.add. I'm adding 10. So here we are adding different type of elements. Now we want to ensure in our collection, we want to add only integers. Then how to manage that is, after this collection class, we have to mention the data type what you want to add. How to mention it? In angular brackets, we need to mention the data type. Reference type only, should be reference type only. I cannot use this primitive type like int. It will go with error. Okay, so we have to mention only reference type over here, like integer. So this side is optional from Java 7 version. Right side is optional to mention this data type. So here now see in this linked list we can add only what type of data? Integer. If you observe under add method of apple we are getting see error. In this line number 6 we are getting error. Now if I want to add string, so just replace this data type with string. So now in our collection we can add only what type of data now? Only string type. We can add only string type. Now see we are getting error under add of 10 here, right? We are getting error here. Now let us add some more elements. LL.add orange ll.add manually sub elements. Now if you print the object ll, how the result will come? Apple, orange, and Mac. See here, it's going to show the elements enclosed in square brackets separated by comma. Now the objective is we want to pull out one element and use it. That we call traverse. How to traverse is can use for. So for enhanced property for what type of elements the list is holding here? String fruit colon ll. So what will happen? It goes to this ll. Pull out one element from this list and stores into this variable fruit. Since it's of type string, we are applying a string here. Now if you print the object fruit, see the result? It's going to pull out one element and displays back to us. So this concept only we call traversing or iterating. Got it everyone? Any questions? No. Moving to the next one, set interface. Set interface. So what is the use of set? Set is an unordered collection of elements. Set does not allow duplicate elements. In set, no duplicate elements. Classes under set interface. The classes under set interface are like asset. Asset is what? Unordered and no duplicate elements. Linked asset. Linked asset is ordered and no duplicate elements. Tree set. Tree set is what? Sorted and no duplicate elements. Complete set, no duplicate elements. Now let us understand these three classes using a program. Set it. Import util package. Let us initially go with asset. Just to create object of asset, add the elements. hs.add monitor, hs.add keyboard, hs.add mouse, hs.add UPS, hs.add speakers. So we are adding some elements. Now if you print the object hs, see the result how we get. See here, the way we add it, are you getting in the same order here? No. So here we added with monitor, but here it started with keyboard. So this is the meaning of unordered. This is the meaning of unordered. Okay, so asset is what here? Unordered. Now, if you add the element hs.add monitor. See, already we have added monitor. Again, we are trying to add the same element monitor. See the result now. So is that monitor getting added here once again? No. So whenever we are adding an element into set, it's going to check whether that element already existing or not. So if it is already existing, then that element will not get added. That is the meaning called as duplicates are not allowed. So you can check it here. Call this method in system.out.println. So if the element is added, it's going to return true. Unable to add, it's going to return false. Since it is a duplicate element, it is unable to add. It's going to return what for us? False. Clear all of you the meaning of unordered and no duplicates? No. Coming to the next one. Linked asset. Linked asset is what? Order. Create object of linked asset. Create object of linked asset, add the elements. Now if you print the object LHS, the result will be, so the way we added, the way we get. So first we get monitor, then keyboard, mouse, UPS and speakers. The way we added, the way we get. That's meaning of audit. Next one, tree set. Tree set is what here? Sorted. Create object, tree set, ts equal to new tree set, then add the elements, ts dot add. Now if you print the object ts, then the result will be alphabetical order, ascending order by default. By default, ascending order. So first which one goes? Keyboard, alphabetical order, then monitor, mouse, speakers and UPS. By default, it is ascending order alphabetical. If you want to go with the descending order, then we have to call the method ts dot descending set. So when you say ts dot descending set, then first it's going to show UPS, speakers, mouse, monitor and keyboard. Right? Now so when we run, we get the same output what I have given in comments. Any questions, anyone? No. Here we are having one important rule. To the tree set, if I add an element like 10 here, see the output what we get? We are getting an exception here, class cast exception. Because tree set is mainly for what purpose? Sorting. So whenever you want to sort the elements need to get compared each other. If the elements are of same type, then only they can get compared each other. So if you are adding different type of elements, they are unable to compare. That's the reason we get here class cast exception. So here we get exception, class cast exception. So what is the point we should remember? In tree set, all the elements should be of same type, else it will throw class cast exception. Now let us see a realistic application where we can use this set concept. For that, let me take a small scenario. Like, let us suppose we are having a training institute. To the training institute, we are getting inquiries every day. Whenever the inquiry comes, we'll make a note of name, contact number, and codes inquired for. Let us suppose in 6 months we got 6,000 inquiries. In this 6,000 inquiries, is there any chance of having duplicate inquiries? Yes, right? Because the same candidate might have inquired for different courses or same course multiple times. But whenever the inquiry comes, we are not worried about duplicate. We'll maintain a record of it. Now we want to send an SMS to all the inquiries that we are starting Java batch at so and so date. But before we send SMS, we want to remove the duplicate mobile numbers. So is it a easy task to remove duplicate mobile numbers out of 6,000 mobile numbers? Difficult, right? Complex part. So manually it is very, very complex. So this is the place where we use softwares. Now, let us develop this application. Simple. Write a program to remove duplicate mobile numbers from the given list of mobile numbers. From the given list of mobile numbers, we want to remove duplicate. Let us go to the program, remove duplicate. Import within. Here let us go with the list integer mobile numbers equal to new array list or linked list. Then add the mobile numbers. Mobile numbers dot add. I'm just going with 4-digit mobile number here, like this 1111 222 333. Again 1111 duplicate 444 555 333 duplicate 666 777 and 555 duplicate. Now if you print the mobile numbers, the result will be 1111 222 333, again 1111 because list allow duplicates 444 555 333 666 777 and 5. Now from this list of mobile numbers, we want to remove duplicate. So whenever your thinking goes to remove duplicate, your thinking should go to what? Set interface, like this. Set integer unique mobile numbers equal to, you can go with asset, refer to asset if you are not worried about audit. Linked asset if you are worried about audit. Reset if you are worried about sorted. Here let me go with linked asset. Linked asset of integer. Now simply say unique mobile numbers dot add all. We are having a method add all. To this we need to add mobile numbers. So whenever you want to add a simple element, we use add method. When you want to add one collection into another collection, one collection object into another collection object, we use add all. Since we are adding this list of mobile numbers to this unique mobile numbers, since it is set, it's going to remove the duplicate numbers from this given list. Now see, if you print this unique mobile numbers, now the result will be 1111 222 333 444 555 666 and 777. So whenever we want to remove duplicates, your thinking should go to what? Set here. See that result here. The duplicates has been removed. Clear this code? Any questions? Instead of adding these elements this many times, we can make use of one concept here. Collection factory method of added in Java 9 version. Added in which version? Java 9 version. So how to use is simple. Just to say list integer mobile numbers equal to, just you can say list dot of. Of is a static method present in list interface, and just add these elements separated by comma. That's it. So instead of going with this many times add method, we can simply add the elements to the list using collection factor method of here. Same result, no change in the result here. Right? Any questions? No. Moving to the next one, map interface. So what is the use of map? Map is used to collect the elements in the form of key value pairs. Map is used for what? To collect elements in the form of key value pairs. Map does not allow duplicate keys. No duplicate keys in map. Similar to set. Classes under map. Hash map. This is unordered based on keys and no duplicate keys. Linked hash map. Linked hash map is ordered based on keys and no duplicate keys. Tree map is sorted based on keys and no duplicate keys. Complete map, no duplicates. Let us understand using program map demo. Right click on collections and say new class map. Import util. Let us initially go with hash map. Create object of hash map. hm input new hash map. Now here, in order to add the elements, we use the method put method. So here put method takes two arguments, key comma value. So let us take the key like monitor and the value of the monitor. Similarly, hm.put keyboard, the value of keyboard. hm.put mouse, the value of mouse. hm.put UPS, the value of UPS. hm.put speakers, the value of speakers, like this. Key value pair. Now if you print the object hm, see the result of it? The values are enclosed in between curly braces. Every key value pair is separated by comma and key and value is separated by equal to. And this is unordered. The way we add it, we are not getting that way. So it is unordered. Now, this is unordered based on this. Now, if you go with linked hash map, linked hash map is ordered based on keys. So create object of linked hash map, LHM equal to new linked hash map. Put the elements. Now if you print the object LHM, how the result will be? The way we added, the way we get. That is monitor 5000. Keyboard, mouse 300. UPS, speakers 1000. Yeah. Next one, tree map. Tree map is what? Sorted. Sorted based on keys. So create object of tree map. tm equal to new tree map. Put the elements. Print the object tm. Now it is sorted based on keys, alphabetical order. First it goes with the keyboard 500, monitor 5000, mouse 300, speakers 1000, UPS 2000. Alphabetical order based on keys. If you want to go with descending, we have to call the method tm.descending map. So when you say ts.descending map, it comes in descending order. UPS 2000, speakers 1000, mouse 300, monitor 5000, keyboard 500. Right? Simple. Now so when we run, we get same result what I've given in comments. Got it, everyone? So just based on the requirement, we have to choose the correct class here. That's the main part of developer. Writing code is very simple. Just we have to use the methods. Now the next one, the last concept. Now we want to pull out keys and values separately. Means I want to iterate the maps. Iterating or traversing maps. In order to iterate the maps, we have to follow some steps. That is, get the keys of map into a set. Get the keys of map into set like this. If you are having hash map, string comma integer, hm equal to new hash map, string comma integer. So we are applying generic here. So what is the generic? Key is of type string, value is of type integer. Now from this map, we want to pull out the keys. How to pull out the keys is like this. Set string, y string, keys are of type string, keys equal to call the method hm.keyset. So whenever we call the method hm.keyset, from this map, it's going to pull out all the keys and stores into this case. Iterate the keys present in set. Now iterate the keys present in set. How to iterate is simple. For string k colon keys. Keys are of what type? String type. That's the reason here string. Then it's going to pull out one key from this key set and stores into k. Now in a scope, we print the key, then our own separator colon, and how to get the value? hm.get of key. So we are having get method. To the get method, if you pass the key, it's going to return the value of the given. So whatever the key you pass to the get method, it's going to return the value of that key. So that only we are passing. Let us write the code. Iterate map demo. Iterate map demo. Import util package. Now create object of hash map. Apply the generic here. String comma integer. Key is of type string, value is of type integer. Now put the elements into your map. Now see, when we run this piece of code, the values are coming in between curly braces, enclosed in between curly braces. Now we want to pull out the keys and values separately. So for that, iterate here like this. Set string keys equal to call the method hm.keyset. So when you call the method hm.keyset, it goes to this map, pull out only the keys and stores into this case. Now iterate the case. For string k colon keys. So now it's going to pull out one key and stores into k. Print the value of key, print the key and value present in the given key. How to know the value? Using get method and pass the key. So to the get method, if you pass the key, it's going to return the value of that given key. Now see, when we run, it's going to pull out the key separately and values separately, and I'm able to separate the values using our own simple code here. Right? So this concept is important. We'll use more of this concept when we come to frameworks. So when we come to frameworks like Hibernate and Spring, we make use of collections more. Right? Any questions, anyone? So in tomorrow's class, we'll go with one more new concept, Java 8 version features. So here we discuss about functional interface, Lambda expression, stream API, like that. Okay. So this week we'll complete our core Java. Thank you all. Thank you.